Hi, my name is Gregory Light. I'm a technical account manager for AVL Mobile Technologies Incorporated. What's really nice about the AVL solutions for simulation is that it presents a platform or an environment to be able to simulate either components or systems in a virtual world, and allows them to work with variations of those components and systems and adjusting parameters to run simulations against different situations or even environmental situations, and get results that they can look at before prototypes are even built. The benefit from this is a big reduction in time and a big savings in cost, and even more so, the ability to explore simulations or test scenarios that ordinarily you can't do because of time constraints or environment constraints or just the unit under test constraints in the real world. So say, for example, test facilities being restricted, or let's say if you're in ADAS or autonomous simulation, it's very hard to make sure that it's snowing or raining when you want to test a camera system, the camera vision system. Where in simulation, if you have autonomy simulations, you can have an environment model where you can control that. You can control the rain, turn it on and off. You control the rain density. You can introduce fog. You can introduce snow. So the simulation really enables you to get a lot more done quicker and easier, and then broaden that space up to make sure you get a good coverage of the design space and the conditions that you want to test, validate, and verify your system. So the simulation space really helps projects advance and get things done faster. And that's just with simple simulations. The next level would be scalability. That would be where you take your system simulations and you put them in a cloud environment or a high performance PC, and you do parallel simulation or parallel execution. So you're not just doing one simulation at a time, you might be doing 10 or 20 or 50. So imagine being able to run autonomy scenarios, 20 at a time instead of one at a time. Another aspect or component of our solutions that's available too is a product that's an optimizer tool that we can add to that. It's AI based, and it can look at all these results simultaneously and pick the best results. So we have solutions that allow our customers get weeks or many days and weeks of testing done in a fraction of the time. So they're very beneficial in cost and time, and then being able to explore areas that they ordinarily wouldn't be able to do in the real world. We have solutions that are available for more and beyond the traditional space of passenger car vehicles. We offer solutions that work for heavy duty applications, even agricultural, tractor and plow. We have a solution that customers use to do simulations with that as well. And we have solutions that work for other markets as well. One product that we have that's good for particle-based simulations of fluid dynamics. It can help with not just vehicles, but say even an e-motor or e-machine for a washing machine, right? It also works, say, for tires. So there's products that we have that go beyond just the normal vehicle, the passenger car vehicle that you see on the roads. They work for other systems. We're working on solutions. We have projects ongoing with customers that are in aviation. That's another application or field of application our solutions work for. And marine. We're in marine as well. So yeah, definitely beyond the automotive space in other areas. We got one product that's helping aviation develop their propulsion system. In aviation, that propulsion system, part of it being the power generation and then the drive unit. We have solutions that help with the marine, same thing, propulsion system. And then in agricultural, even systems that help with this drive system as well too, the propulsion system. And then the vehicle dynamics. And some of those solutions help with, from a concept phase to do like feasibility studies, all the way up into development of like the full vehicle system and its dynamics. And then, you can even step into where we do what we call hybrid test beds, where we'll combine part of that virtualization that's normally done in an office environment to where prototype hardware is starting its phase, and they're in a test bed environment. And we'll combine that and call it a hybrid, where you have virtualization combined with real hardware testing, which is beneficial because then you get to have real results from a hardware system feeding input to a virtual system that's not yet developed, and then seeing how it interacts from the inputs, and that interaction give you output results that will go back into the real hardware system. So you're able to get results of what you're virtualizing and see what closed loop real-time results are like before you even build a product. There's another big benefit to it, allowing where normally engineering teams tend to be somewhat isolated. They work on their component here, and this group works on their component. But if you bring them together, especially from the simulation world, the calibration world, and the test world, if they start working together, it breaks up that isolation and really brings true cross-functional engineering together and helps accelerate these projects, meet their expectations and their timelines quicker, and even discover, let's say, better optimizations or more robust results. Yep.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.